Hello, this is cantilever beam of total length 1 plus 1.5 plus 2 plus 0.5. 1 plus 1.5 plus 2 plus 0.5, that means total length 5 meter, and at point B there is 3 kN downward load, concentrated point load. Between C to D portion, that means on 2 meter portion, this UDL 1 kN per meter UDL acts, and at point E concentrated point load downward 2.5 kN. So we need to find SFD and BMD of this beam, cantilever beam. So first draw pre-body diagram. Pre-body diagram, that means remove support, remove this fixed support, and draw reactions. Fixed supports have three reactions: vertical AY, horizontal AX, and movement. Now judge shear force diagram of this beam. This judgmental shear force diagram is right or wrong. After that judgmental SMD and BMD, we will calculate exact values for that SMD BMD and draw exact corrected shape. First judge it. This is BMD. Before that, see, deflection of this cantilever beam is like this. Here at A it is 0. So this is hogging deflection, like this, hogging. That's why movement comes negative. Remember this. Now draw shear from left to right. First see reaction AY. Due to reaction AY, shear goes upward. See arrow. Between A to B there is no load, so horizontal line. At point B there is 3 kN downward, so it is downward like this. At point B to C there is no load, so it is like this. At point C to D there is uniformly distributed load, so it is like this inclined line. UDL, that means shear is inclined. This is like this incline. D to E there is no load, so horizontal line, and again drops down. So this is positive shear. This is only judgmental SMD. This might be wrong or might be correct. I don't know. This is finalized after corrected numerical calculation. So judge bending moment also. At point A, some bending moment generate, and this bending moment is hogging. That means negative, like this. At point B, A to B no load. That's why this is like this. Again B to C no load. This is like this. And at C, there is UDL. So UDL, that means parabolic curve up to D. And at point D to E, there is no load. That means inclined line. So this is negative. Now calculate reaction first. C reactions. vertical positive, downward negative. So this AY is vertical, minus 3, 3 is downward. This 1 kiloton per meter acts on 2 meter distance. That means convert this UDL into point load. This is 1 into 2 is 2 kilonewton point load and act at a distance of center of this CD. That means 2 by 2 is 1 meter. So this positive AY minus 3 minus 2 minus 2.5. So this AY is 7.5 kilonewton. Now see shear force diagram. Up to this point it is 7.5 kilonewton. In between this there is no load. That means up to here it is 7.5 similar, and due to this 3 kilonewton it goes drop down. So 7.5 minus 3 it is 4.5. So here it is 4.5 kilonewton. B to C no load, that means at point B it is 4.5. Shear force unit is kilonewton. So this is positive 4.5, and at point D, C positive 4.5 minus 2, it is 2.5. So here 2.5. Here also 2.5, but this drops down, so here it is 0. So our shear force diagram, maximum shear force is 7.5 kilonewton. This is corrected. Now calculate moment. Calculate moment at this point. Clockwise positive, anti-clockwise negative. This 3 kilonewton is clockwise, so positive 3 into distance from 3 kilonewton to that point is 1 meter. So positive 3 into 1. This 2 kilonewton is clockwise, so positive 2 into 1 plus 1.5 plus 1, that means 3.5. Again this 2.5 is also clockwise, so positive 2.5 into distance is 1 plus 1.5, 2.5 plus 2, 4.5 plus 0.5, that means 5. So it is 22.5. Plus mx plus 3 into 1 plus 2 into 3.5 and plus 2.5 into 5. So mx is equal to minus 22.5. Now calculate moment at this point, B point, from left side. So AY into 1, AY is 7.5 into 1 is 7.5 into 1 is 7. See this mx also, positive mx plus 7.5 into 1, that means minus 7.5. So at point B is minus 7.5. Now calculate moment at point C. See that point, left side to that point. This AY force, this mx force, this 3 force, this AY is clockwise, that's why positive 7.5 into 2.5. This 3 is anti-clockwise, so minus 3 into 1.5. Again this plus mx, so it is minus 14 point, no, positive 7.5 into 2.5 minus 3 into 1.5. So it is, calculate it again. So positive AY into 2.5 minus 3 into 1.5. Positive 7.5 into 3.5 minus 3 into 1.5. AY is 7.5 kilonewton. See, this mx, this 7.5 calculated is wrong. Because why it is wrong? Because we need to consider this mx value also. This mx is this 22.5 kilonewton. So calculate moment at point B again. AY is clockwise positive. AY is 7.5 into 1 plus 22.5. This is clockwise, but value is minus 22.5. So positive 7.5 into 1 minus 22.5 is minus 15. Here 15. Now calculate moment at this point. This is minus. So this positive 7.5 into 2.5 minus 3 into 1.5 and minus 22.5. So it is 8.25. Unit is kilonewton meter. Now calculate moment at this D point. Calculate moment at this point. See right hand side forces. This 2.5 into 0.5. It is clockwise 2.5 into 0.5. It is 1.25. Change sign. When we see forces from right hand side, then change sign minus 1.5. 1.25. So it is minus. So this is 22.5 is hogging bending moment. So our judgmental shape is correct. And here between C to D portion, this is parabolic curve. See, dV by dx is equal to xw, that means loading. Dm by dx is equal to minus v, that means shear, and d square m by dx square is equal to minus w. That means if this w is 0, that means this shear is constant. See, this w here is 0, w here is 0, so shear is constant line. See this second, if this shear is constant line, then this movement is inclined line. See this shear is constant line, this movement is inclined line. If this w is 0, then this movement is inclined line, second order higher. See here, this here load is 0, movement is inclined line. So this is relation between movement and shears. Now see same SFD BMD in StatPro software also. click on new, unit is metric, type is analytical and create. So total length of this beam is 5 meter, 2 plus 2 4, 4.5, 0.5, 5 meter. So here 0, node 1 is 0 and node 2 is 5 meter. Create model by using node or mesh. Add beam, add. Give some properties for errorless calculation. We are interested in solving shear force and bending moment for live load only. Add, close. Assign to view, assign, yes. Material, concrete, assign to view, assign, yes. Now next is support, create, fix, add. Fix support, that means all are restricted. Use cursor to assign, assign. Translation, rotation, all are restricted. Now loading, load case details, add. Loading is live load, title give title live load, add, close. So 3 meter from A point, it is 3 kN load acting at B point and it is 1 meter away from point A. So member load, uniform concentrated force minus 3. 3 is our 3 kN is our downward load and this direction is gy, y is upward direction, that's why I write here minus, because my load is downward. Minus 3, select this beam. Minus 3 is at 1 meter, so d1 is 1. See this diagram. Change, close, assign to view, assign, yes. Now second load is CD portion 1 kN per meter. So from A, this UDL starts from 2.5 meter and end at 2.5 plus 2, that means 4.5 meter. 2.5 and 4.5 and load is 1 kN per meter. This gy direction load minus, because of load is downward, load is 1 kN per meter, d1 is starting point 2.5 meter and d2 is ending point 4.5 meter. Add, close, select this, assign to view, assign, yes. Right click, labels, scales, distributed force, reduce the scale. Apply, click on apply immediately. So applied force is correct. Now at point E there is 2.5 kN downward force. Member load, concentrated force minus 2 minus because of downward and d1 is 5. Add, close, select this beam, assign to view or assign to view, yes. So loading is applied, support is applied, total beam length is 5 meter. Now analysis, define command, all, add, close, run analysis. Go to post processing. First see deflected shape. Now see deflection. This Y in inches. Maximum deflection is 0.107. That means it is 2.72 mm maximum deflection at middle of this beam. Now see shear force value. This is 7.5 kiloton shear. Here see 7.5 kiloton. Here it is 4.5 kiloton. See 4.5 kiloton. And here 2.5 kiloton. This value we will see here. Go to analytic mode and double click on this shear bending. Type here 5 with 0. Add 5 0, yes. And at 4.9 it is 2.5. See, this is 2.5. Just left to that. Now see instead how STAD shows bending moment and sign convention. Hogging bending moment shows positive. Let's see values are 22.5, 22.5 is correct, 8.250, 8.25 correct, 0. See middle values, analytical modeling, double click, shear and bending, at a distance of 4.5. It is 1.25, see 1.25. At a distance of 1, see 15. That means our manually calculated and software calculated SFD BMD is correct. Thank you very much.